Today we're going to be talking about composite shapes, what they are, and how to find their area. Here we have polygons. These polygons are a rectangle, which is a quadrilateral, a parallelogram, which is a quadrilateral, and a triangle. All of these are under the polygon umbrella because they're all closed shaped that have straight sides. So you start getting to the specific name quads and tris based on the number of sides, but they are all polygons. Down here we have composite shapes. These are shapes that are made up of a combination of different shapes. So the easiest one to see right off the bat is the circle one that has the triangle shape taken out of it. And so here you can kind of divide here and see that we have two triangles. Here we would have a rectangle and a triangle. So these are composite shapes, and today we're going to work with learning to find the area of them. We will discover that using what we know about the area of polygons, which is any closed straight line shape, will help us find the area when we have an odd shape. So for an introduction, there should only be one eye, not two. Some shapes do not have neat little formulas to help us solve for their areas. In the past week, we have found the areas for different polygons: rectangles and squares, triangles, parallelograms, trapezoids, and circles. These all had formulas that are on the star chart. But what if we had a shape like this one here? It's kind of an odd little shape here. Well, we're going to go through the steps on how to break it apart. The first thing we want to look for is any familiar shapes that we know, such as the ones listed above, those ones that have the formulas that can help us. So when I look at this shape, I look at to see that if I extend this line right here, right there, I would have a rectangle and a triangle. So step one is to look for familiar shapes. Step two is to find any missing measurements I may need. When I created this triangle right here, there are no numbers attached to it. It's just an odd shape. So I need to discover from the numbers that are given to me how I can go about getting those numbers, because if you remember from the formula for a triangle, we need base times heights, and then we divide that in half. So let's look at what we have that can help us. All right, I'm going to have to put my thinking cap on for a little bit. This side, and I also have my highlighter going, this side right here is 7 inches from that corner to that corner. I know that up here it's 4 inches. So if this total is 7 inches and I take 4 inches away, because this is a straight polygon, it's a straight rectangle, it's a 90 degree, we know that's perpendicular, I will have that missing piece. So 7 minus 4 is 3. That 3 gives me the height I need for my triangle formula. So now let's look at this base here. This base runs from right there to right there. And so if I come across, we can see that this whole side is 5 inches. Well, this part right here is only 3 inches. If I subtract 3 from 5, my total length minus that side, I get 2 inches, which is what that side is made up of. So because I'm able to use deductive reasoning from the information they're giving me, I have now found my base and my height of that triangle, and so now I will be able to solve for the area of each shape, which is step 3. So let's look at our formulas. We have them on our chart. We're not creating them out of anything, but I know that the area of a rectangle is, hopefully you're already doing it, base times height, and the area of a triangle is base times height divided by 2. So now we just have to be careful about subbing in the numbers. So the length of my rectangle is this side right here, and it goes all the way down. So 5 inches is 1, and you need to be careful. I don't want to pull 7 inches because 7 inches goes the entire length of both shapes. I want this one right here that is 4 inches. So I'll put that in there, and we know that 5 times 4 is 20, and that is inches squared. So let's look at the triangle. The triangle, and I'm going to try and use my highlighter here, is this length right here. And so again, we need to make sure we're pulling the triangle's measurements. And so we have 3 times 2, and we divide that by 2. So 3 times 2 is 6, divided by 2, and I would have 3 inches squared. That leads us to our fourth step. We need to add our measurements of our area together. So there we go. Now that shouldn't be that hard with these measurements. So I'm going to come over here, and I'm going to find a spot, and I'm going to have 20, which is from here, and I'm going to add it to 3, and we get 23 inches squared as the total area for that shape. Now if you look at this right here, this upper box, this just kind of breaks it apart for you of how we're really doing the two different shapes and how they're pieced together. You sort of have to do that in your head, especially when they get to be more than just two pieces, is pull them apart and always know which pieces the numbers go with. And so there we go with that one. Now we're going to go down to this bottom, and we are going to find out what to do when we're asked to find out the shaded area, the area of the shaded part. So that means I need this shaded area, but not that one. So our first step again is to see if there's any familiar shapes that we need to find. In this case, there's not. So we're going to be skipping step 1, but we need to know that it is there. We can plainly see that these are both squares. How do we know that? They only give us one measurement. They look like a square. And if they don't tell us anything else, that's what we need to assume, that those sides are all congruent. So with that, we are going to solve for each area. And so the formula for my area of a square is area is equal to side squared. So that would be our next step, is now step 2, solve for the area of each shape. So using my formula, A area equals side square, I can do my largest one and substitute in my side. So A is equal to 3 squared. Please remember that that is 3 times 3. So that is equal to 9. And again, I can do that with my smaller square. A is equal to S squared, which is equal to 2 squared, which is equal to 2 times 2, 4. So I have found the area of each square. Now I have to subtract to find what remains. That is step 3. So I have 9, and I'm going to take 4 away from it, and I would have 5, and our units is centimeter squared. And so what that's telling you is that if this is your shape and that is not there, what is this shape in between there, in between the two lines? So there we go. So what it's really asking for is the area of that shape right there, so with not including that center part. And so the last one is to make sure you write it with the correct units. Squared. So I just want to point out this part over here. Just like in the above problem, this is a visual model that shows the subtraction part, that we have this square and we're taking out the area of this square to see what remains, just like we kind of marked up the other one. For your classwork, and what I want you to do is the second two. We'll do the first ones together. and we'll check these when you come into class tomorrow. So the first one is find the area of the polygon. We have shown you how to separate the shapes with a dotted line. You will need to find the missing measurement and the total area. So, and we even put the formula there in case you don't have your star chart. So let's look at this first shape. I'm going to outline it in yellow. And we're going to go with this shape right there. All right, so we can see that the sides that we need, or the numbers that we need, are 3 and 7. We're going to get those because they're there. We don't have to find them, but the rectangle, this length goes from this edge to that edge, and then this is from that to there. And so you can see that we need those measurements. So let's do that one out real quick. Area equals base times height, which is equal to 3 times 7, which 3 times 7 is equal to 21. And so we can write that over here, 21, and it would be centimeters squared. So let's look at the second one. It is this shape right here. We can see that 2 centimeters is the height of there, but we need to know what this part is right there. We need to know the length of that side. So what we have, what they give us is the total length right there. That total is 15 centimeters. I know from what I just did that this side right here is 7 centimeters. There we go, now it's working. And so if I have 15 and I subtract 7 from it, I will get 8 remaining. And so that is that 8 centimeter size, because this guy is the total, and this is a part, and this is the other part that makes up that whole length. So let's do that one. We have area equals base times height, which is 8 times 2. And remember, you can write multiplication several ways. On my iPad, it's a little easier to write it with a dot. And that would equal 16. And so over here we would have 16 centimeters squared. So what I'm going to do with this one is add. And so we would have 37 centimeters squared as our total for the whole shape. And so what that would mean is that this whole, this whole area inside all the shape, the whole shape, the composite figure is 37 centimeters squared. So what you're going to do is you're going to do these two on your own, like I said at the beginning. You're going to do these two on your own. This one here, I'll go ahead and give you a hint. This you're going to be adding, and this is a subtraction one, because in here you need to find out if that hole was cut out, what that shaded area would be. And in here you're using the area of a trapezoid and the area of a rectangle to find the area of that composite shape. So we didn't get confusing with the numbers. We extended the dotted lines to help you see that the length of that side is between those dotted lines. So that's all that that means, and that's why they're extended. It was just a little tight there with the numbers, and a lot of times that's the way you'll see it tested because it just looks a little more confusing. So what I would like for you to do is to do these two, bring them into class. We'll be checking them first thing, and then we'll be going on to our assignment. Rock on, kiddos, you're doing great.